in fact, so we're looking at problem number 44 from the homework. Now, in the original problem, it doesn't have this here. It has x squared minus 4. So we need to make sure we factor everything that's factorable. Well, what you were doing was not wrong. It's going to add a few more steps. Because if you'd have left it as x squared plus, or x squared minus 4, you'd have the x squared minus 4 being multiplied on top and bottom, along with everything else. And I wouldn't write this at this point. Because x plus 2, x minus 2 is going to be necessary, because x plus 2 does show up in each of the denominators at least once. It only shows up in once in most of them where it does show up. X minus 2 shows up in each one of them once. Now, if we added the x squared minus 4 on top and bottom, we're actually multiplying the top and bottom by an additional x plus 2 and x minus 2. It's not that it won't work out, it just means, so x, because multiplying it by that extra one means that x plus 2 and x minus 2 is fine, it will go in, but it's going to have to come back out. Anything over the least common denominator will factor back out. So it's just adding more steps. So whenever we do this and with solving, we don't want to go above the least common denominator, which in this case is x plus 2 and x minus 2. Now when we multiply through the numerator, the top we get 3 times x plus 2 times x minus 2 over x minus 2. Minus 6 times x plus 2 times x minus 2 over x plus 2 times x minus 2. On bottom, we're going to get 3 times x plus 2 times x minus 2 over x plus 2 plus x plus 2 times x minus 2 over x minus 2. Now on top here, the x minus 2 and x minus 2 will cancel. The second one, the x plus 2 and x minus 2 cancel. On bottom, x plus 2, x plus 2, x minus 2, x minus 2. Now what that leaves us with on top is 3 times x plus 2, minus 6. On bottom, we have 3 times x minus 2 plus x plus 2. Now, we could have left the parentheses around the x plus 2, but it's not going to make any difference because the sign in front of it's plus, not minus. On top, 3 times x is 3x. 3 times 2 is plus 6, minus 6. On bottom, we'll distribute it. 3 times x is 3x. 3 times negative 2 is negative 6. Plus x plus 2. Now, on top is nice because our 6 minus 6 is 0, leaving us with 3x. On bottom, 3x plus x is 4x. Negative 6 plus 2 is negative 4. Since 4x and negative 4 have a 4 in common, we can factor out, giving us 3x over 4 times x minus 1. Yep, that's it. Because just in the numerator alone, if we had left the x squared minus 4 in, this is where we would have ended up, at 3x cubed minus 12x. well, we can see here that the extra two factors of x plus, well, the extra factor of x plus 2 and the extra factor of x minus 2, two more than we needed, took the degree on top from 1 to 3. Because really all this is 3x times x squared minus 4. On bottom, we're going to have that x squared minus 4. It's going to come out anyways. Bless you. So anything above is going to give us more work. Does that make sense? That's why we want to try to avoid going above that least common denominator. So questions on this here? I think we did this one already, yes? Yeah. Okay. Now we're going to solve one where we have 3 denominators. Now, one of the things I didn't point out too much on Friday, but whenever we're solving, we need to make sure the denominators are simplified or factored as far as we can possibly get. And part of the reason I didn't bring it up Friday is, well, and it won't come up too much today, is that the denominators are as simplified as they can get. X, 4, and x are factored as far as they can go. We can't do anything with them. Now, the restrictions are places where x could be 0 in the bottom, where we could have a division of 0. There's only 2 places out of the 3 denominators where we could get a 0 in the bottom of the fraction. And that's our x or x. And x cannot be what? 0. So here it instantly x can't be 0. That's it. Least common denominator. And we can set it up like we've been doing, LCD, and then compare the 3 denominators to each other. So if we look at this here, we do have x, 4, and x, yes? X shows up in 2 different denominators, yes? In each of those denominators, how many times does the x show up? Once, yes? So let's multiply through just by x first. If I multiply through by a single x, this first x here and this x will simplify out completely. In the middle, the 4 and the x won't, but in our last one, the x and x will. So here we only needed a single x. Anything else left in the bottom of the fraction? 4. So we also need to multiply the whole thing by 4. And in the middle, the 4 and 4, there we go, will cancel out. Now, it is very tempting to want to multiply by x squared, but we would only need to multiply by x squared if one of the denominators had an x squared, an x to the 2nd power. We had 2 of them. But since the x has only showed up once in each of the denominators, we only need it once. Let's see what we're left with. And the first one, we have 5 times 4, which is 20, plus 7 times x is 7x is equal to negative 9 times 4, which is negative 36. Now, since we don't have a variable with an exponent greater than 1, we just need to get the x by itself. So yes, we can subtract 20. Telling us that 7x is equal to negative 56. And lastly, we would divide both sides by 7, telling us x is equal to negative 8. Now, if we wanted to check, we could. And what that would involve is just replacing every x in the equation with negative 8, giving us 5 over negative 8 plus 7/4 is equal to negative 9 over negative 8. And what I would do is come in here and say, that's it. So we'd have 5 over negative 8 plus 7/4, giving us 9/8. The other side, we had negative 9 over -8, which is also 9/8. So all that tells us that when we plug in -8 into this equation for x, it tells us that 9/8 is equal to 9/8. That's a true statement, so it is the solution. Questions on this here? Solve this equation here. Now our two denominators are x and x minus 5. Yes. Now both x and x minus 5 are as simplified as factored as far as they possibly can go. The x by itself can't be 0, so we'll set it equal to 0 solved. Well, it is solved. X can't be 0. The x minus 5, well, we can add 5 to both sides, telling us that x can't be 5. Now if we solve this and get down to the bottom and have either x equals 0 or x equals 5, we throw it out. Just mark it out. It doesn't work. It's an extraneous solution. All right. And that's helpful for us because especially when we start solving and these restrictions come into play, we don't really need to check because the restriction tells us outright, these are the ones that don't work. I don't have to individually go back and plug them back in. Now, least common denominator, we need to figure out what we need to multiply through to get the fractions to go away. That's one thing we know we'll have to multiply through. X minus 5. Now the middle one, the x minus 5 and x minus 5 will cancel because one of the ones on bottom cancels with that one on top. Do we have any other x minus 5s? No. Do we have anything else on bottom? X. Okay, so I'm also going to have to multiply through by x. And this x over here and this x here will cancel. So sometimes this works out nicely. We just take it one set of factors at a time, multiply through, and then check and make sure, are the fractions all gone? Now at this point here, are they all gone? Yeah. So that means we found the least common denominator is x times x minus 5. So we finish multiplying through. Well, 1 times x minus 5 is x times x minus 5. Minus our 8 times x, which will give us minus 8x times 3 is equal to 3 times x minus 5. So sometimes if you're having trouble seeing what the least common denominator is with these here, take it one set of factors at a time, multiply it through. If we said we multiplied through by the x minus 5, simplified one on top and bottom, and one of them still had an x minus 5 on bottom, we would do it a second time. But here, they all simplified out on the first time. We don't have to do it a second time. All right, let's distribute. X times x is x squared. X times negative 5 is negative 5x minus 8x is equal to 3 times x is 3x, and 3 times negative 5 is negative 15. We're going to combine like terms, giving us negative 13x. Now at this point here, we need to get this equation equal to 0. The main reason is because we have an x squared. First thing we can do is subtract 3x from both sides. Then we can add 15 to both sides, telling us x squared minus 16x plus 15 is equal to 0. Questions on this here? Now there's 3 main ways, or well, 4 ways that we can solve this. We can solve it by factoring, graphing, completing the square of the quadratic formula. Here, factoring will work on this here. Graphing also works well if the number in front of x squared is 1 and there is no greatest common factor. Because if it's 2, check for greatest common factor first. But we can graph this and see if we do have solutions. Here. So we can go y equals, we can type it in and graph. And look for where it crosses the x-axis, what values of x will make the y value be 0. So here, that is the wrong problem, because it should be minus 16, and that should be plus 15, and we get this here. Now, when we look at this one, y, the x value is 1 when the y value is 0, so one of the solutions is 1. And 15. Now, if we did factor this, it would factor to x minus 1 times x minus 15. Because since the third term is positive, the signs are the same and match the sign of the middle term. We get negative and negative. Only factors of x squared are x and x. Factors of 15 are indeed 1 and 15 or 3 and 5. 3 and 5 are going to be a little small. Now that we have two things multiplied together to equal 0, one of these is going to be 0. And it tells us that x is 1. And x is 15, which we did find by graphing. The only time graphing won't work as nicely is if, one, the solutions are not rational integers, or we have to find the fraction. But this is it here. Questions on these so far? All right. 3 over x plus 5 halves equals negative 12 over x. Frictions. Now, we do have three denominators. We have x, 2, and x. Now, all three denominators are factored simplified as they get. We can't simplify x or 2 any further. 2 can't just magically become 0, so the only place we can get a 0 is at x or x. And both of those would actually have the same value of x. So x cannot be 0. Questions on this so far? Now we need to multiply through to get rid of these fractions. Well, what can we multiply through by? X. And we can start there. And the first one, this x and x are going to cancel. Nothing in the middle one, and then the other one, the x and x. Do we have any of the denominators left? 2, so we'll also need to multiply through by 2. And that last 2 on the bottom of the fraction will cancel with that 2. Leaving us with 3 times 2, which is plus 5 times x is 5x equals almost negative 24. Now we need to get this equation equal to, or get the x by itself. So we can do what? Minus 6. Telling us that 5x is equal to negative 30. Divide both sides by 5. Telling us that x is equal to negative 6. So this one here, we only have one solution, and that's fine. Now, say it worked out that the restrictions for this was negative 6, we would throw that out. We would mark that solution out. But since that was the only solution left, or the only one we have, and it's the restriction, it means that this would be no solution. Yep. Thank you. Questions on any of this here? We're going to look at one more. Restrictions. X minus 4 and x. They are factored, they're simplified. But neither one of these can be 0. So for us here, our restrictions are at 0 and 4. Because if either one of those is a solution, it would give us a division of 0. We have to throw it out. So let's see what we need to multiply everything by. What's one thing we'll need to multiply through? X. And here the x and x will cancel out. We'd also need the x minus 4. And in the middle, the x minus 4 and x minus 4 will cancel. And what that leaves us with is x times x minus 4 minus 2x is equal to 4 times x minus 4. We're going to distribute here. X times x is going to be x squared. X times 4 is negative 4x. Minus 2x is equal to 4 times x is 4x. And 4 times negative 4 is negative 16. Now we do need to get this equal to 0. Doesn't really matter what we subtract first, because we can either subtract the 4x from both sides, giving us x squared minus 10x is equal to negative 16, and add the 16. Or we could have added the 16 and then subtracted the 4x. Order on those two really doesn't matter. Because either way, we should get to x squared minus 10x plus 16 is equal to 0. Now, since the third term is negative, our signs are going to be the same and match the sign of the middle term. Since the third term is positive, the signs are the same and match the sign of the middle term. I feel like I just said it was negative. Factors of x squared are going to be x and x. Factors of 16, 1 and 16, 2 and 8, 4 and 4. 2 and 8. And those indeed would be the correct factors. Add 2 to both sides, get x equals 2. Add 8 to both sides, showing us x is equal to 8. And since neither one of those are our restrictions, those are our two solutions. Questions on this here? And that's it.